Our next speaker is Thomas Ressa. Thomas fell in love with the ocean after a trip to the island of Moorea in French Polynesia as a kid. After 10 years working for big tech companies like Apple and Amazon, he took a leap of faith and joined this program to pursue his passion of working in coral reef ecology. Since arriving, Thomas has been singularly focused on learning all he can about the science, ecology, policy, and restoration of coral reefs. He is hyper-focused on his career and future in this field of coral reefs, and I'm excited to see his dream realized in the coming years. For today, the title of his presentation is Restoration Destination, the one-stop shop for all things coral restoration and the Florida Reef Tract.
Thank you. Okay. This is a coral larva. Kodian Jelsma is a research biologist from Mote's International Center for Coral Reef Research and Restoration. He shared this video with me during a day of volunteering in his lab in Summerlin Key, Florida. This time lapse was taken over the course of 2 days and shows how the early stages of a coral's life are spent searching for that special place with just the right parameters to settle and call home. Nobody is sure what causes a coral to choose any one location, whether it's flow, lighting, some sort of chemical composition of the substrate, or a combination of several elements. This is just one of the focal points of research being conducted to improve coral restoration success. For me, this video was a bit of magic. I've always wondered what those first few days of a coral's life look like, but in all the combing through scientific articles and my own experience in the aquarium hobby, this was the first time I was able to gain such a unique perspective. So many of my colleagues know I came from a non-marine science background, but I knew coming into this program that I wanted to work in coral reef restoration, which is in its infancy and information is relatively scattered. So I wanted to ask the questions. Where is coral restoration happening? Who's doing the research? What methods are being practiced? Where have they identified successes and failures? And most importantly, how do I get involved? So what you might not know is we have the third largest barrier reef in the world right here in our own backyard. The Florida Reef Tract stretches 330 nautical miles from Martin County on the east coast of Florida to the Dry Tortugas National Park, which lies west of Key West. Our barrier reef is only dwarfed by the Great Barrier Reef of Eastern Australia and the Mesoamerican Reef that stretches the Caribbean coast of Central America. These are the type of questions that led me to pursue this project and ultimately create a space designed to highlight everything from the current threats to the Florida Reef Tract, how the Mission Iconic Reefs project, which I'll introduce a little bit later, plans on addressing those issues, and answer as many questions as I could relative to coral reef restoration. In the early months of this program, I had a book recommended to me titled Life and Death of Coral Reefs. I was immediately met with chemistry, physical oceanography, and even geological history, a fantastic read for anyone interested in the history of coral reefs. But the language was complex, and I wanted to master the basics to help with my own communication of the subject matter for this project. I'm going to take you through a quick crash course on corals just to get you all on the same page. So the building block stony corals that are the focus of Florida's restoration efforts are from the order Scleractinia. That's not the most important piece, but bear with me. Like most corals, they have a symbiotic relationship with zooxanthellae, a single-celled dinoflagellate that are present in soft tissues, which provide food for the coral through photosynthesis. Recent studies have also identified that corals feed heterotrophically from the water column as well. Those soft tissues, or polyps, are an individual coral animal. They live inside a hard, cup-shaped skeleton called a corallite. Calcium ions are absorbed from the water by the polyps and secreted as calcium carbonate. These thin plates are progressively laid down like bricks underneath the soft tissue and form the hard substrate of the coral reef. Most polyps are small and live together in what are called colonies. Colonies are usually genetically identical polyps that can number in the thousands and form beautiful corals like this massive Parietes colony nicknamed Big Mama from the National Park of American Samoa, documented at over 40 feet across and 20 feet tall. In Florida, we're talking about an ecosystem that was only 30 to 40 years ago dominated by large branching corals like Acropora cervicornis and Acropora palmata, better known by their common names, the staghorn and elkhorn corals, both of which now find themselves on the endangered species list. I had a really eye-opening story shared with me during my visit to the Keys. Quote, Back in the late 70s and early 80s, if you went diving in the Florida Keys, you were almost guaranteed to come back to the boat with scratches and cuts all over your body because you were navigating through dense thickets of elkhorn as you chased around the abundance of underwater life. Now, I'll admit, that was hard for me to imagine, but it really opened my eyes to the need for swift action if we're going to bring this precious ecosystem back from the brink of extinction. So, what is Mission Iconic Reefs? In 2019, the National Oceanic and Atmospheric Administration and a team of partners, including the Florida Keys National Marine Sanctuary, the Mote Marine Lab, the Nature Conservancy, Coral Restoration Foundation, and others, began what will likely be a 15 to 20-year undertaking to design, build, and execute a plan to bring Florida's coral reefs back to its former glory. Their goal is a multi-phased approach that involves physical removal of invasive species like lionfish, restoring native coral species like elkhorn, staghorn, pillar, and star corals, and even introducing algae-grazing fauna like the Caribbean king crab to help clear the reef to allow for more successful natural coral settlement. It's clear that this will not be an easy task, and it will take the work of many, from a wealth of volunteers to the collaboration of Blue Star certified dive shops, Ocean Guardian school programs, and of course, courageous legislative action. So for my project, I partnered with the National Marine Sanctuary and the NOAA Mission Iconic Reefs team to help design and build their website. I'm using this space to highlight the restoration work, the organizations, and the research, all in an attempt to make it easier for people on the outside looking in to get involved. I've always been somebody who learns by doing, and I was incredibly lucky to be able to travel to the Florida Keys to connect with some of the people working on this project. I got some hands-on experience that provided me with a better understanding of the skills that are needed and what kind of work volunteers and citizens alike can get involved in. If I can do it, my goal with this project is to make sure that you can too. During my research trip, I collaborated with the Coral Restoration Foundation, Mote Marine Laboratory, Reef Renewal USA, and even Dr. David Vaughn, founder of Plant a Million Corals and one of the most well-respected coral biologists in Florida, who discovered the microfragmentation method that is being used by restoration practitioners today. All right, with that experience, I'd like to share what I've created. This website was made with the goal of increasing awareness as well as highlighting the coral reef restoration work that's occurring in the Florida Keys. During my research, I found that there wasn't one place to go to get information about who's involved, the volunteer opportunities that are available, or even geographically where exactly the work was taking place. So I created Restoration Destination so that anyone searching for information about the Florida Reef Tract or coral restoration in general can find my directory and dive in. I want this website to appeal to anyone who, like me, loves the ocean and wanted to take the first step to educate themselves and find a way to make a positive impact. Immediately, you're met with a stunning close-up from a nursery where fragments of staghorn coral are growing out before reaching maturity and being planted back onto the reefs. As you navigate down the page, infographics and quick bits of information tell you about the importance of Florida's coral reefs, from their economic impacts to the history and geographic significance of the sites chosen for restoration. Vivid imagery complements bold text designed to draw the user in and encourage engagement. Want to learn more about coral reef restoration? By clicking the Learn More button, you're taken to a page that highlights the 3 most common methods of coral restoration being used today. Microfragmentation was discovered basically by accident. By dropping a coral, it had split into several pieces that were observed rapidly growing and even fusing together to develop into new colonies, a strategy now used to speed up the growth of species like brain, boulder, and star corals. Larval enhancement. Within the last few years, we've been able to identify the lunar cycle that triggers spawning events, which occur one night per year during the late spring and early summer months. By collecting the egg and sperm and bringing them back to the lab, we can assist in the early stages of coral settlement, a process that aims to increase survival rates and genetic diversity among coral communities. And artificial reefs. A group called Reef Design Labs is using new 3D printed structures to help with coral regeneration efforts by providing substrate for new corals to settle on and a place for fish and other marine life to call home. With the assistance of interactive diagrams and detailed photography, my hope is that visitors will engage with the content while learning something new. I've integrated an always available drop-down menu that can take you to any page on the website. For example, on the 7 Iconic Reefs page lives an ArcGIS map I created to highlight the geographic significance of each of the 7 sites chosen to be restored by the Mission Iconic Reefs project. If you navigate to any one of the points on the map, you can click to get more information about the particular site, from GPS coordinates to before and after images, even what unique characteristics that specific site may have. This is only one of the myriad of ways that GIS can assist in bringing data to life through stunning visuals and story maps, as seen through some of the work of my colleagues. My hope is that we can build a better understanding of this incredible ecosystem that's right here in our own backyard, something a lot of people may only think exists on remote islands throughout the world's oceans. There's an About Us section as well. This page was designed to give more specifics about the Mission Iconic Reefs project, its history, the environmental challenges that the wildlife is facing, and most importantly, highlighting the partners that are involved in the program. Every icon is a link to more information about how the individual organization is contributing to the efforts to restore Florida's coral reefs. On the bottom of every page, users are encouraged to share their contact information to stay up to date with the latest news, volunteer opportunities, and all things social media. The Donate Now tab takes you directly to the Mission Iconic Reefs donation page. All proceeds go directly to the National Marine Sanctuary Foundation and help those organizations assisting with the efforts. So, how does this differ from anything else that might be out there? I set out to create a website that would collate the most relevant information to make it easier to navigate and present it in a way that hadn't been done before, by encouraging visitors to get involved through volunteering, donations, and even just sharing information through social media. I believe engagement at all levels will be greater, with the potential to motivate policy, the ultimate goal. I wanted to give a special thank you to Dr. Stuart Sandin for introducing me to the Iconic Reef Stewardship and Community Engagement Work Group in the Florida Keys, to Dr. Brian Zaglinski for the countless emails and Zoom meetings and always being positive and providing endless feedback, to Heidi Batchelor for all things GIS. Her passion and positivity were essential during this project, to Chase Martin for all the help on the website, from designs and layouts and things that someone with less experience would definitely overlook, and to my family for all the late night conversations and inspiration to keep going and working hard. I love you. Thank you.
Thomas, what was the most eye-opening fact you've learned in your research about coral reef restoration?
So I had no idea that corals reached sexual maturity based off of their size and not their age. So the microfragmentation process I was talking about, if you think about like an upside down bowl, for example, that's made out of ceramic, and imagine like 20 little fragments of coral on top of that. When they're broken up into small pieces, they grow really quickly, and they have a tendency, if they're from the same genotype, to fuse together. So they can get corals to grow to a sexually mature age very quickly and then transplant that out on the reef, and they actually have observed them spawning within a year's time. So that was spectacular.
And what would you say is your biggest takeaway from your Capstone project experience over the last few months?
I would say you got to put yourself out there. It's incredibly challenging to, obviously with the coronavirus situation. I was lucky enough that I got to travel. That was huge for me. I feel like I'm the kind of person who always learns by doing something. And so if the opportunity presents itself, you really need to dive in, even if you're uncomfortable in doing so. And doing so alone was a challenge for me, something I don't normally do. So that was probably my biggest takeaway.